So I have the pleasure to entertain you for the last 20 minutes of this afternoon after almost 2.5 hours non-stop presentations. I'm going to tell you something what we did in task 5.4 of this SCCER. The work I'm going to present was mainly done by Sandra Markus, who happens to be on holiday this week. So the content of my talk is a few words about my institute, then what we do in this task 5.4, who are the academic partners involved, what are the objectives. In this task we are the contact point of all power-to-gas demonstrators in the SCCER, and I'm going to present those 4 demonstrators briefly. One of them was already introduced very detailed in my previous talk. And then some summary at the end about where we are in this task 5.4. So this is my team working on power to gas at the University of Applied Science in Rapperswil, and we have a homepage, a YouTube channel and a Facebook page giving you some more information. So in task 5.4 is a response to critics in phase 1 of the SCCERs. There were different demonstrators popping up at in different work packages, and the board said there should be a coordination of all those demonstrators, and that's what we do in the phase 2 of the SCCER. So the 4 power-to-gas demonstrators we coordinate is our own. We call it high-efficiency power-to-methane pilot, and the abbreviation is HEP. I'm leading the team. Luis de Sousa, he's the project manager of this project, and Sandra Markus, she's coordinating our project with the other demonstrator activities. Then we have the Grid to Mobility demonstrator here in Martigny by EPFL Valais. And it's Hubert Giraud who is leading the team. You've seen him this morning. And Heron Wrubel and Veronique Amstutz. And I think after my talk and the coffee break there we can visit this demonstrator. Then demonstrator number 3 is the small scale demonstrator in Sion, which has been presented to us just now. It's Andreas Züttel's group and Norris Gallant. I have to mention, the 2 of them, they saved my life this morning because I forgot my poster at home, and they printed one out, so I had a poster in this morning's poster session. Thank you. And then number 4, demonstrator number 4 is the Energy System Integration Platform by the Paul Scherrer Institute, and there Peter Jansson is here. And Marcel Hofer and Tilman Schildhauer are the other researchers involved in this ESI platform. So the objective of our task is to improve power-to-gas systems. And each group works on the same objective, but it's on its own power-to-gas demonstrator. The 4 academic groups design improved power-to-gas systems, so every group has improvements on current state-of-the-art power-to-gas system, and each group uses state-of-the-art laboratory technology and tries to bring them to something like TRL 6, which is in a real system environment. So the results from 2017 are that all academic partners have designed, ordered and installed their research equipment. Some of them are a little bit ahead, others are a bit later. And we have organized several meetings between the groups, and we have exchanged our experiences and successes and and failures as well, and we have come to some preliminary conclusions. So the current status of the energy storage demonstrators. First, our own HEP by HSR. These are our partners, the logo of our partners. You can see academic partners who provide technologies to our plant. And then there are also partners from industry who provide some financial funding. And we are quite glad that we can report to all of the SCCR quite some third-party funding from this demonstrator. It's part of this demonstrator is a part of the EU project Pentagon, and yeah, the pointer doesn't work. So the Pentagon logo, that's the Pentagon logo, and then the other partners, they contribute financially to the other tasks which we do outside this EU project, but which belong to our demonstrator. So the demonstrator is located in Rapperswil, and the installations will be finished in the middle of 2018. Our research question, the primary research questions is improvement of efficiency of power to methane technology. State-of-the-art technology is about 50% efficient with respect to the higher heating value, and we want to increase this to up to 70%. And then we want to answer industry-relevant questions for scale-up and investigating system behavior, and we want to include other innovative technologies developed in Switzerland. Here we can see the layout of the plant. It's a conventional path of a power-to-methane plant with a conventional electrolyzer and a fixed-bed methanation reactor. It's 10 kilowatt electric power. And the new feature is an SOEC delivered by EPFL Valais, Dr. Van Herle from Sion, who will deliver this SOEC. And well, first of all, SOECs are more efficient than conventional electrolyzers. And then second, in the methanation, you lose 22% of the upper heating value in heat. And we want to use this heat to generate steam. And the SOEC splits steam instead of liquid water. So part of the energy input into the electrolyzer is not electricity, but it's the evaporation enthalpy in the steam, and this leads to a higher efficiency because to create a certain amount of hydrogen you need less electricity. So that's the effect which we want to achieve. So then we have other new methanation technologies coming out of EMPA and University of Applied Science Zurich. We want to include a new membrane gas treatment technology from APEX, and also a new low-cost gas analysis system from a company called MEMS. In addition to that, well, main technical features, it will be a 5 kilowatt solid oxide electrolyzer cell. We will have waste heat management, which will use the waste heat from the methanation. We will use new catalysts for methanation here in this reactor, a new membrane separation technology, and a new gas analysis technology. And around all of this, we would like to have some features that allow to demonstrate this, what we're doing here, to the general public, like a car that's important, a fueling station, grid injection. We have a PV installation, and we have a device that captures CO2 from the atmosphere. Okay, next demonstrator plant is the grid to mobility demonstrator, Martini. It's a demonstrator designed and run by EPFL in Martigny. Some first results will be expected in 2018. So the research questions are better understanding the chain between grid and renewable energy and electrical vehicles due to increase of electrification and transportation. And they want to investigate the changes in the electrical grid infrastructure, introduction of renewable energy sources, as well as energy storages. So this is the layout of the demonstrator. It features a redox flow battery and an alkaline electrolyzer, as well as a PEM electrolyzer. Then a charging station for electric vehicles. Then the hydrogen coming from the electrolyzer is pressurized by two systems working on compressed air. And this is a hydrogen filling station with 350 bar as well as 700 bar. The compressed air, so the air compressor the waste heat from the air compressor will be used in the metal hydride hydrogen storage installed. So the current yes, I was also told the EPFL team is building a PEM electrolyzer, and the stack was commissioned from a third party, and now the balance of plant is being designed and built. And the alkaline electrolyzer is from McPhee. It has been modified by the team and is now operating. And there is a system for purification of the gas which is under construction and evaluation. And the hydrogen filling station is already operating. Okay, small-scale demonstrator CO. I think I can make this part quite short because the previous presentation included the most important parts. So it's an installation of average 2 kilowatt, which is the average energy consumption or power consumption of a single person. And it seems to be the only demonstrator which is really hooked up directly to the PV panels. In our case, we have the grid in between the PV installation and our plant, but here it's really directly connected to the PV panels. Yes, that's the layout which you have already seen. And this is a reactor to generate methane, and this is a reactor to generate methanol. And what you also will notice, there is no conventional compressor here, so it's only a, well, the electrolyzer works at 13 bar, and there is a metal hydride compressor pressurizing this hydrogen to a pressure of 50 bar, and that's will be more or less the operation pressure of the methanol reactor. Okay, I think this. Okay, this is the demonstrator number 4. It's the ESI platform by Paul Scherrer Institute, and it's already operating. It has been opened. Can't remember. 2016, I think. Yes, was the opening, and it's an experimental platform for research and industry. So the research questions answered there. It's a research and technology transfer for the SCCR's heat and electricity storage and for BioSuite. It features a hydrothermal gasification, methanation of waste from food industry, which is a wet bio, let's say a wet biomass, from which methane is produced. One other feature is part of the plant was installed in Zurich for a certain time. Now it's back at PSI. And in Zurich it was methanating real raw biogas from from the biogas plant in Zurich. And one important part which will be investigated is a first new catalyst synthesized based on metal organic frameworks. So this is the layout of this demonstrator. It's much larger than all the other demonstrators, and it features a 100 kilowatt PEM electrolyzer from Siemens. Then it has gas storage tanks for hydrogen, carbon dioxide and oxygen. There is a 10 kilowatt transportable methanation unit called Cosima. This is Cosima. This is the one which has been installed in Zurich for a certain time. Now it's back at PSI. Then it has a 2 kilowatt transportable hydrothermal gasification methanation. It's called Conti C. And this part is a 160 kilowatt synthetic natural gas pilot scale fluidized bed methanation plant. It's called Ganymed. I'm informed that the demonstrator is in the final phase of implementation. There were some problems, well, in all demonstrators there are always some problems. Here there were some problems with gas purification plant, which have been solved. And the Ganymed part of the plant is expected to have a warm commissioning in spring 2018. And in the future, they plan to install also a microgas turbine and a container for a second fuel cell module. Okay. So I come to the last part, assessment of energy storage demonstrators. I can't present any real results yet. But I want to make some remarks on the joint activity, CEDA, which is called Coherent Energy Demonstrator Assessment. It's a joint activity between several SCCERs, and the aim of this joint activity is assessment of the investigated storage and conversion techniques of heat and electricity storage demonstrators. On base of the results, the scale-up of the technologies can be investigated to determine the impact of the technologies on a country-wide level. So in this activity there are 3 of the 4 demonstrators which I have shown are included. So it's our demonstrator HEP, it's the ESI platform, and it's the Grid-to-Mobility demonstrator here in Martigny. And in addition to that, it's MOVE from EMPA, NEST from EMPA, and EHUB from EMPA. So you can see there is a lot of discussion and a lot of exchange between all those different demonstrators. So actually, all these technologies are defined with their input parameters, output parameters, and the next steps will be that all these parameters will be defined, where to measure them, and what is included, so what is included in this measurement and what is not included. And these parameters will be quantified from real measurements of these energy storage demonstrators during the year of 2018. And then the task of this joint activity is also to upscale these measurement values. It's quite a challenge because you see here the demonstrators are quite different. It's not only power to gas demonstrators, but it's also different demonstrators, and that's quite a challenge to do some comparison between these demonstrators. So the state of the work of these coordination activities, the scientific exchange of know-how between all those academic groups has been started during this year. Discussions about common parameters and assessment methodology will yield some results in 2018. The measured data from the energy storage demonstrators can be expected in 2018, and we hope to get some publications in 2019. And the coordination we do within SCCR heat and electricity storage, we will be feeding our results into the joint activities of SEDA. Okay, so this is my presentation. I think the last slide is this slide everybody has to use, and I'm really looking forward to the further cooperations between those 4 academic partners and all other groups I meet within this SCCR. Thank you.